Hello students, so today we are going to perform the next practical, that is the implementation of a convolution code. Now the aim of this particular practical is to implement the convolution code. Learning objective is to study encoding and decoding using a convolution code. The tools which we needed for performing this particular practical is a Matlab. Now what is a convolution codes? The convolution code uses a smaller block of messages. These blocks are called as an information frame. This information frame consists of one or more symbol, and the code word is obtained using a current frame and previously information frame, that is a convolution code, have a memory. The output sequence V in a convolution code can be obtained by convolving the input sequence M with the impulse generator G, that is a V is equals to M into G, and therefore it is called as a convolution code. Now, what the convolution code basically consists of, it is specified by three parameters n, k and m, where n indicates the number of output bits, k indicates number of input bits, and m is equal to number of memory registers or a constraint length. And the quantity k by n is called as a code rate denoted by r, and hence the convolution code can be represented as r by m. And the diagram of a convolution code goes like this. Here S1, S2, S3 are the shift registers which we are using, and we are having this V1, V2, V3 which indicates the output bit, and the input which is applied over here. Now here the shift register consists of the three flip-flops, and the first flip-flop defines the incoming bit, and the remaining flip-flops defines the state of a code at that instant. Now here each input bit is encoded into the three output bit, that is a V1, V2 and V3, and the constraint length of the code is a 3. That is the three output bits are produced by 3 mod 2 adders by adding up certain bits in the memory register. So if you observe over here, for the first output we are adding S1, S2, S3. For the second output we are adding S2 and S3, and for the third output we are adding S1 and S2. So likewise this logic varies. So here just adding certain bits of the memory register, we are generating the output, and the selection of which bits are to be added or to produce the respective output is defined by the generator polynomial for that particular output bit. And here, as I have already told you, B1 is equals to S1 XOR with S2 XOR with S3, V2 is equals to S1 XOR with S3, and V3 is equals to S1 XOR with S2. Now lookup table. Now the lookup table is a very important table. Now here the encoder for the encodation code uses a lookup table to do the encoding. It consists of 4 items. First one is the input bit, state of the encoder. State of the encoder defines the number of shift registers is 4. So the remaining 3, which is number of the possible combinations, that's a true is equals to 3 is equals to 8, and the output bits of the encoder shows a then the output state, which is the input state of the next bit after the current bit has shifted inside the register. And the lookup table for 1 by 2 by 4 code is given below. 1 by 4 means single input, 2 output and 4 number of states. So here we are having the output like this. So here first is your input bit, then we are having the input states. So as the value is 2 raised to 3, so we are having 8 number of possible combination of an input state. Output in this case is defined by 2, so we are having a 2 values of output, and this 2 defines the output states. Okay, so in this way we write down the lookup table. So this is your output state, this one is your input state, and the respective output. And the presentation of a convolution code. So the convolution code is represented into 3 basic format. First is the state diagram. So this is a representation of a convolution code in the state diagram, where we are representing the code in terms of a state diagram. So this circle indicates the current state value. So here as we are having 8 possible values, we are having 8 number of states, and this dotted line indicates the next state, or it indicate the flow of the next state or the value of a next state where your respective input is a 1, and the straight line indicates the output when the respective state is a 0 likewise. Next one is a tree diagram. So in the tree diagram we are representing the convolution code in a format of a tree. So here we start from the current state as a. When input is equals to 0, it will go in upward direction, and when input is equals to 1, it will go into the downward direction, and then in this way the tree is formed, and on the path we write down the respective value of output. and it will move to the next state actually. So when input is equals to 0, what is going to be the respective next state? It will move to in that fashion only. And last and the most important is a trellis diagram. So this is a structure of a trellis diagram. In trellis diagram, again we begin with the current state and we just follow the diagram. So here we begin with the current state as a. So if my input is equals to 0, so what is going to be my next state? The next state is A again, and for that this straight line indicates that your input is 0, and here we have just written 0 is the input and 00 is the respective output. Here this dotted line indicates that my input is 1 and the respective output is 11. So in this way we just draw the trellis diagram. We just continue in drawing until we have finished the all values. So here for the first set we are considering only A as an input. For the second set we are considering A and B as an input node, and from third onwards we are considering all respective nodes. So likewise it is like 1, we are just considering 2, then 4, 8, likewise the number of nodes goes on increasing. So that is the trellis diagram. Now Matlab code for a convolution code. So for convolution code we are using some functions. So the first function which we are using is a trellis function. This is a poly to trellis. Now this is a function which is used to convert your given value into a trellis diagram. So it is represented by the constraint length and a code generator. So the constraint length is the length of a input is a constraint length, and the code generator defines the value of a respective code encoder values, which this respective value of a code generator which is given to us. Now one thing is very important: in case of a convolution code, this code generator value should be in a octal format. So therefore we are converting the given value into the octal representation. Second function which we are using is a struct. Now struct is a function that used to create a structure array with a multiple field. It is like the field 1 and the value 1. So if none of the value inputs are cell array, or if all values input are cell array or scalar, then S is a scalar structure. If any of the input value is a non-scalar cell array, then S has the same dimension as the cell array. Next and the very important is a decode. The function which is used for a decoding, that is a Viterbi decode. So this Viterbi decode is defined as a Vit decode. Code day in, this is a value of a coded output which we are using. Trellis representation of a structure. TB dep is a respective value of the number of state which we are using. Op mode is a operating mode in which we are working it, and dict type is a decision type. So in this case the decision type is hard or soft. So here we are using a hard type of decision. Hard type means we are representing the data in formats of zeros and 1 only. Then the actual code. So the first command by default is a CLC, that is to clear the previous workspace. Then n is equals to 2. This command is used for defining the code word, length of the code word, that is equals to 2. G1 is equals to 110. It declares the first generator vector. G2 is equals to 001, declares the second generator vector. L is equals to 5 is the length of the message, and here we are defining the message bit. So your message bit is 11010. K is equals to 3, indicates the number of shift registers which we are using. MS is equals to M, zeros 1 comma K minus 1. So here what we are doing now, along with this message signals, we are adding a few number of zeros, and those number of zeros are completely based on the number of shift registers which we are using. So this particular thing is used so that the complete data will be passed through the shift register. So to make that, we are just adding more number of zeros so that the complete data or the complete input gets passed through the shift register. Then A1 is equals to number to string. So this function is used for converting the given generator vector into the string. CG1 is equals to struct to decimal, decimal to base, in bracket binary to decimal A1 comma A2. So this particular function is used for converting the given generator vector into the octal format. So here A1 represents the struct. A1 represents the given or this A1 is a representation of given vector into a structure format, and then we are converting that number into the octal format. So therefore this is used, and once we have converted into octal format, we are just recovering it back. The similarly is applied for the second generator vector, and then G1 is equals to CG1 and CG2. This is a final generator vector which we are using in the trellis function. So this is a trellis function. So poly to trellis is a function which is used for generating the trellis diagram or for generating the convolution code. K is a number of shift register, and this CG1 or the CG indicates the value of the generator vectors. Here TR is equals to struct. Now here we are just defining the structure or making an array of an input symbol. So this first is a number input symbol. This value is 2, number output symbol, its value is 4, and the number of state is 4. So your input symbols are given by 2, output symbols are 4, and the states are 4. So in this way we are just drawing an array. R is equals to your received vector. The received value in this case is this value, and finally we need to decode. So the function which is used for decoding is given as decode Viterbi decode R trellis to trunk hard. Now this is a function which is used for decoding the trellis diagram. So once we are done with this, now let's implement the function using a Matlab code. Now let us perform the practical on a Matlab. So I will just go for a new script. So this is my new script. I have already run the program over here, which I have explained with you. So I'm just opening that program. It will take some time. So this is a program which I have explained with you. So I'm just going to run the program. So for running the program, you just have to go and select the run. It was the same program which we have discussed. So here we are giving two generator vectors G1 and G2. A message vector is given to us, and then as the function used for generating the convolution code is poly to trellis, which requires the data or which requires the code word in a octal format. We are converting the data which is in the number format to the string, and again from the string into the octal format. So this is what we are doing over here. So this process we have already discussed, and then this is the function which will create our output, and the output is represented by TREL, that's a trell, and R is a received code word which is we have receiving, and then we need to recover the data, and the function which is used for recovering is a Viter decode. This R is nothing but the received code word. Trellis indicates the trellis diagram. 2 as the number of input in this case is a 2, therefore we have written the 2. Trunk stands for the truncation format of operation, and hard is the structures which we are using over here. So that's what we have done. So once we run the program, we just check the output in the command window. Wait for a while. So this is my output. So MS which we have defining, we are getting the same MS as a message signal. Now here this extra zeros are added. I have already told you what is the need of these extra zeros. These extra zeros are used to transfer the complete data from the shift register. So therefore the extra zeros are applied. Then A1 is a first generator vector. CG1 indicates the conversion of the generator vector into the structure format. Then we are having a B1, this is a 001. So this is just a format which we are just converting the given number into the structure. Okay, that is, we are just writing it in the binary format. This is in the binary format. We are just writing in a decimal format, and then this decimal format we are converting into the octal format. So this is the data. This is my generator vector 6 and 1 in a binary format. So in a decimal format, this is a structure. Structure indicates the number of inputs, output symbols, and the number of states which we are using. So the number of input symbols are 2, then we are having a 4, and then we are having a 4. R is a received code vector, and this is in the decode. So what we have to do in this case now, we just have to verify the data which we have transmitted, so which is our actual data, and whichever we have received is the same. So we are decoding the data. So in this way we perform the practical using a Matlab, and we have already seen in the last practical videos what is the function of each and every block. So once you are done with all this, you just take a printout and attach it to your file. Thank you so much.